Now we're going to do a couple application problems involving quadratic equations. So example 4 says if a baseball is projected upward from a 112-foot building with an initial velocity of 96 feet per second, then its height is a function of time given by h equals. So what is the baseball's maximum height? When does it reach its maximum height? And after it is projected, how long will it take for the baseball to reach the ground? So let's kind of talk about this and let's draw a rough sketch of this on our graph. Here, instead of x squared and x, it has t. So that is my x-axis here. And this is in the form of time. So we have time down here, and our time is in seconds. Okay, then for my y-axis, instead of y equals, we have h. So this represents my height. And my height is in feet. Okay. Now we're starting at a 112-foot building. So I shouldn't have wrote this quite as close to this. So let's say that this is my 112-foot building right here. And this parabola is going to open down because of that negative. Because of that negative out front, it's going to open down. So it starts off this building, going to go up, and then it's going to come down. So for part A and for part B, it wants to know what is the baseball's maximum height and when does it reach its maximum height? Well, looking at kind of this graph, and this is being the trajectory of the ball, what vocabulary have we been using that would talk about this maximum height right here? That's the max height or the vertex. So they're not going to come right out and say, find the vertex, but that's what these are asking for right here. Now, these are asking for different parts of the vertex. One is the x coordinates, one's the y coordinate. So which one is talking about this x coordinate right here of the vertex? That's going to be your when question. When does it reach is talking about time. So even though this is part B, we're going to start right here. It wants to know when is it going to reach its maximum height. For your vertex, you have an equation of x equals negative b over 2a. Now, we're talking about t here, so it doesn't matter really if you want to put x or t. We're talking about this x coordinate here, but in this case, they're talking about the t. So x equals or t equals negative b over 2a. My b is 96. So we have negative 96 over 2 times a, which is negative 16. So we have negative 96 over negative 32. And so this is going to equal 3. So 3 seconds. Word problems need word answers are at the very minimum units. So not just 3, but 3 seconds. So now going back up to part A, what is the baseball's maximum height? Now we're looking for that y, or in this case, the h coordinate of our vertex. To find that y coordinate of our vertex, we just simply plug in our x. So I have y slash h equals And I am plugging in 3 for all of these t's right here. So we've got negative 16 times 3 squared plus 196 times 3 plus 112. So my y or h equal, put that all in your calculator just the way it looks, and 256. Now again, word problems need word answers, or at the very least units. This height is measured in feet, so it has reached 256 feet. Part C wants to know, after it is projected, how long will it take for the baseball to reach the ground? If something is reaching the ground right here, and that's right here, this right here means that my height, my h, equals 0. So I'm simply going to take this equation here, h equals, and put in a 0 in place of that h. So 0 equals negative 16t plus 96t plus 112. I'm wanting to know how long. I'm solving for time right here. Okay, so let's solve. We have a trinomial, so I'm going to try factoring. First thing we look for when we factor, well, I guess first, is it in standard form? So the second thing is GCF, and I do have a GCF here. I have a GCF of 16. So I can pull out that 16, but because I'm actually solving, I'm going to divide everything by negative 16. I'm going to take that GCF and just simply get rid of it. So now we have 0 equals t squared minus 6t minus 7. So now let's try factoring. My a times c is 1 times negative 7. My b is negative 6. What adds up to b and multiplies to ac? To get to negative 7, that's just 1 times negative 7, or negative 1 times 7. Did I say the same thing twice? It's negative 1 times 7, or 1 times negative 7. And so because this is negative, my bigger number needs to be negative. So this will be 7 and 1. This is at least an easy trinomial. So that means it factors to t minus 7 and t plus 1. And when we solve, we're going to get t equals 7. Again, my time is in seconds. Or that my t equals negative 1, which is still in seconds. This answer here does not make sense. And what would happen is if this continued into that second quadrant over here, it would cross right here at negative 1. But I can't really go back into time unless I can, make a time machine. So my answer here is 7 seconds. So when it wants to know when it will reach the ground, that means your height is 0. And so what it's actually asking for here is simply the x-intercept. With these application problems, you're finding the exact same things. They're just not going to come out and say, find the vertex. They're not going to come out and say, find the x-intercept. You have to kind of understand the shape of the graph and what it's asking, and then you're finding the same things. Now, number 5 is going to be a setup only question. This is a question in my math lab. It says a rain gutter is made from sheets of aluminum that are 30 inches wide by turning the edges to form a right angle. Determine the depth of the gutter that will maximize the cross-sectional area and allow the greatest amount of water flow. So this is supposed to be part A and B. I will fix that as well. Okay. So write the quadratic formula for the area of A in terms of X. I think that's another typo. This needs to be write the quadratic equation. Or it might even say find the quadratic function. But not formula. So we need to write the quadratic equation or write the quadratic function for the area A in terms of X. And I'm actually going to assume, since it says A in terms of X, that that's supposed to say function right there. So if I'm wanting to find the area here, you have this straight sheet of aluminum, and it tells us here that it is 30 inches wide. And so I'm going to take some number on both of these edges. Could be 5, could be 2, could be 10. I don't know what it is, but I'm going to take some amount of that 30 and I'm going to take it and I'm going to bend it up. So now this doesn't exist, and I take this and I'm bending it up. And so this doesn't exist. So this is my gutter right here. And so that 30 minus 2x is because it's 30 total. And then we're subtracting this number and this number. And x minus x is 2x. Now this side right here will be x, because you're taking whatever you're taking here and you're turning it up, right? So if this is my shape, I have a rectangle. And your area for a rectangle is length times width. The length is this 30 minus 2x. And the width is that x. So you could probably leave your equation or your function just like this, but it's also not that bad to just distribute in that x. So I would say your area is 30x minus 2x squared. So I have my formula, or I have my function or my equation here, and what kind of graph is this going to make? Well, because of that x squared, it's a parabola, and because of that negative, that means it's going to be upside down. So I'm going to have some parabola that's opening down. Now, part B says the depth x that will maximize the area is the same as the x value of the blank. Okay. I went ahead and I put this into the graphing calculator. And here is my graph. And so exactly what we predicted, it's going to be a parabola facing down because it's x squared and negative. Now, talking about x and y, my x right here represents how much I am folding in. So if I'm folding in 5, if I'm folding in 8, whatever the case is. And then my y is my a that represents the area, right? And if I'm wanting to know the maximum area, again, what are we talking about in terms of this graph, of this shape? We're talking about the vertex. So you can use your formula here of negative b over 2a to figure out how much do you need to bend that in. And then you can plug in this x value to then get the y to figure out what the max amount of area is that you can make this rain gutter. So again, that key word here is maximize. When you see maximize or maximum, that is screaming to you vertex.